Okay, welcome everyone. Welcome to this webinar focused on geographic scaling of ecological footprint and biocapacity, hosted by the International Ecological Footprint Learning Lab. So my name is Eric Miller, and I will introduce this webinar and our presenters, and I'll moderate a discussion following the presentations, which we invite you to be a part of. I'm the co-director of the International Ecological Footprint Learning Lab, which is a project hosted by York University and its Ecological Footprint Initiative, of which I'm the founding director. I'm speaking to you from Hamilton, Ontario, on the Canadian shore of Lake Ontario, near Toronto, where York University is based. This geography has shaped humans and indeed has been shaped by humans for many generations. Millions of people reside in this area today, which is the traditional territory of many Indigenous nations, which have long-standing relationships amongst each other and to the geography of this part of the planet. Our research team at York feels that our work honors and respects York's land acknowledgement, such that our work supports and can inform the peaceful sharing and caring for the Great Lakes region and for the whole planet. Today's webinar addresses the question of how ecological footprint and biocapacity can be scaled to various geographies, which ties into questions of why this is valuable research, how it can be done, and how this research can be applied. There are, of course, many applications which are typically related to geographies in which we derive ecological footprint and biocapacity, setting forth the possibilities and some limits and constraints around those applications depending upon those geographies. Before I introduce our speakers, I will briefly introduce the concept and measurement that our speakers will address and why geography is so fundamental to engaging with these concepts of ecological footprint and biocapacity. In simple terms, ecological footprint is a measure of human demands on and for ecosystems, and biocapacity reflects the biological capacity of ecosystems to support human demands as measured by ecological footprint. All ecosystems, of course, exist within a spatial context, and so ecological footprint and biocapacity are inherently geographic. Elaborating on this definition, we can say that ecological footprint refers to the surface area of the planet which we directly occupy with settlements and infrastructure, plus the aquatic and terrestrial areas which we harvest or cultivate to provide us with food and renewable materials, plus the area of ecosystems needed to sequester anthropogenic emissions. Ecological footprint is a composite measure with its components typically labeled as built-up land, fishing grounds, cropland, grazing land, harvested forest lands, and the area of forest needed to sequester anthropogenic emissions. Within this framework, it is possible to add components to account for other human demands on or for ecosystems, and we can do this in ways that avoids double counting. Ecological footprint can be measured for any aggregation of people, from an individual or a household to a community of people, or among all people within a city or watershed or province or state or country, or indeed for all of us on planet Earth. In other words, it can be measured for humans within any defined geography. Now, biocapacity refers to the capacity of a specific geography to support an ecological footprint, and biocapacity and ecological footprint are measured in the same units so they can be compared, because both are anchored in time and space such that it reflects rates of regeneration or sequestration. You will hear from our speakers today talking about global hectares, which is a local hectare converted to a standardized global unit based on that local hectare's biological productivity relative to the global average of all other biologically productive hectares. Global hectares allow for global comparisons. Now, the phrase ecological footprint and its framework vision was introduced over 30 years ago by Professor William Rees at the University of British Columbia. Geography and place and space were foundational to the concept, which was first articulated as a way to measure the areas of ecosystem beyond a city's boundaries, which are appropriated effectively by the consumption taking place within the city's boundary. Since then, the research from around the world, indeed, has contributed to innovate and evolve the methodologies and data sets related to ecological footprint and biocapacity. And on this one webinar, you will hear from and learn from a sample of this awesome research and its applications to various geographies. So next in this webinar, we will hear from three speakers. Our first speaker will be Jennie Moore, presenting on the methodology and the derivation of ecological footprint and biocapacity at a local basis, building on her work over decades innovating this concept and its application. And so we're so grateful to have you join us. After Jennie concludes presenting, we will hear from Les Kuzyk about driving ecological footprint at a very local level of neighborhoods within the city of Calgary. And then we'll hear from Peri Dworatzek about driving ecological footprint and biocapacity at the scale of all cities and census subdivisions across the province of Ontario. All three of these presenters happen to be in Canada, but their work relating to Canadian geographies is very relevant and transferable to any other geography. Our audience at this moment is joining this webinar from across the planet, not entirely across the planet given the time zones, but certainly spanning continents, of course, covering North America, including here in Canada, United States, and also attendees from Mexico as well, also including across the ocean from Iceland, the Netherlands, Sweden, the United Kingdom, and many others. Thank you for joining us. And with a recording of this to be posted on our research website, I hope if you're watching this recording on the website, I hope you'll find this also to be relevant and inspiring to your geographies of interest. All three of our presenters are also collaborators on the International Ecological Footprint Learning Lab, which is a global partnership to train the next generation in sustainability informatics and undertake research and knowledge mobilization to enhance the measurement and application of ecological footprint and biocapacity. After the presentations, I'll speak to how you can join the partnership and engage with its research. So next we will hear from Jennie Moore. Dr. Jennie Moore is Director of Institute Sustainability at the British Columbia Institute of Technology and leads its ecoCity Center of Excellence. She was the program convener of the 2019 ecoCity World Summit held in Vancouver and serves as a core advisor to the International ecoCity Standards. She is a creator of the ecoCity Footprint tool that helps cities and citizens to identify pathways to sustainable consumption and lifestyles. She has served on the UN Habitat Urban Monitoring Framework Task Team and leads the International Union for the Conservation of Nature's Technical Working Group on the telecoupled impacts of cities on global biodiversity. Previously, she was Metro Toronto Vancouver's first air quality planner in charge of climate action, the first demand-side management planner, curbing consumption to address bioregional capacity, and the first coordinator of the Sustainable Region Initiative, developing a sustainability framework to coordinate and guide the development of regional plans. So welcome, Jennie, over to you.
Just present very quickly on the methodology. I was very fortunate. I'll give a little story for some context. I was very fortunate to be a master's student at the time that my supervisor, William Rees, was working with then Matisse Wackernagel, PhD student, on developing the ecological footprint concept and metrics. Then I went on to work, as Eric mentioned, at Metro Vancouver for a decade, working on climate action, demand-side management, and Sustainable Region Initiative. And it always puzzled me why we weren't working with ecological footprint. So I asked the director of regional planning, and he said, well, it's too simplistic. You know, it's a good communication tool, but it doesn't really help us track things. And so it always puzzled me because I saw the potential for this tool and really felt that it spoke directly to sustainability, having to figure out how to live within Earth's carrying capacity. So when I went to BCIT, they sponsored my PhD. I'm so grateful for that. And I went back and did it with Bill Rees, and I wasn't allowed to use any of the Global Footprint Network's resources. I had to develop ecological footprint as a planner would, who had worked on sustainability for 10 years. So my methodology comes from a energy material flows analysis and organizes the data the way that cities in Metro Vancouver organize their data. And I think that's really important because then, of course, in order to do an ecological footprint, you still need to rely on the equivalence factors and all the public data that's out there around it. So it is still an ecological footprint, but not necessarily organized in the same categories as traditional footprints are. And so that started to get some traction. And so I guess the main theme here as I get into the presentation is look for the ways that the data are organized to serve the audiences that you want to serve. Because when the city saw that it was their data being reflected back to them as opposed to an economic input-output data that they don't work with, they were much more receptive. And of course, I think the value is to merge these sets because the economic input output is more comprehensive. But in order to make it make sense to cities, they need to see it as their own data. So with that, I'd like to first acknowledge that the British Columbia Institute of Technology is located on the unceded traditional territories of the Coast Salish nations, comprising the Squamish, Musqueam, and Tsleil-Waututh. And we're very, very fortunate and privileged to be able to work, live, and play here. So to start very quickly with the structure and sequence of the data, and then I'll get into its applications. It's a component bottom-up methodology that was already pre-described from Matisse's work, looking at energy and material flows. So we start with materials, tons of gigajoule or tons of wood, for example, liters of water, gigajoules of energy, kilowatts of electricity, and then we start to migrate that over to is there a land component associated with that? Is there a CO2 equivalent component to that? And then we extract just the CO2 because that's what nature can sequester, and then we convert it into global hectares. The schematics in the domains of consumption, we're working with food, buildings, so not housing, but buildings, including residential and institutional buildings, consumables, and waste. That's the municipalities manage waste, but we want the front end. So we're always thinking about circular economy, transportation, and then water. And in each case, we take those domains of consumption and work them into materials, embodied energy, operating energy, and then built area. And then we do it in residential, institutional, commercial, and the small I is industrial, because anything exported we don't count, but we do count our imports. Then again, this is the same, but more detailed for the food, for the buildings, for the consumables, for the transportation and water. We can show the data in these categories of embodied, operating, energy, built land. We can also show it by categories that make sense to users, like the types of food you might consume, or the different types of buildings, or the elements of consumables. So is it textiles? Is it rubber, e-waste, etc.? So this is just an example of what the screens look like in the tool, where you can input data and then a lot of the calculations are pre-formulated in the data. It gives you your outputs both as a scope 3 greenhouse gas emission inventory and our scopes 1, 2, and 3, and a footprint. And it also then gives you graphical data. So this is for transportation around, you can see the embodied energy and materials in the roads, in the vehicle fleet, et cetera. So people can start to see where the biggest emission sources are. For food, we can do it by that embodied energy materials, or we can flip it for any category, not just food. We can flip it to the kinds of domains and subdomains that make sense to people, dairy, or in vehicles, heavy duty vehicles, light duty vehicles, motorcycles, et cetera. So it's really based on an integrated energy material flows and life cycle assessment that derives these output products. And for us, interestingly, the municipalities are most interested in greenhouse gas emissions and scope 3 emissions, which seems to be challenging to calculate. So the ecological footprint we also bring to them, but they're really more interested right now in the emission inventory. So the ecoCity footprint tool can spit out a whole bunch of different kinds of data on the ecological footprint, on the scopes 1, 2, and 3, where compliant with most of the GPC and other greenhouse gas emission reporting protocols. And we can look at material flows, urban metabolisms. We can look at the Vancouver or any city's footprint against what the world biocapacity is and what one planet living could look like. So we can have some of these scenarios and then show in the subdomains of categories. So there seems to be a lot of interest in presenting the data in this way. We're working with over 30 municipalities around the region, including the Capital Regional District and Metro Vancouver, which is where the majority of the population lives. But we also are working in more remote, smaller communities across the province as well. And the City of Vancouver used this research to support their Greenest City Action Plan. They actually had an ecological footprint category target in their plan, and they did it because they finally felt comfortable with the way the data was being presented to them. So if cities are comfortable with the data, they will report it. If it's a black box or they don't use the data and they're not comfortable with it, there's a resistance. So I think this is the biggest bridge we need to cross in terms of connecting with local governments or households. We also, because we had the city data, we could break it down to household levels. So we did a green block initiative. This started by a community at Riley Park, one of the neighborhoods in Vancouver, where we presented at a household level. So for 3 years, 20 households tracked their ecological footprint in a neighborhood, and we fed the data back to them and showed them how their footprint progressed from 2013 to 2015. And the outcome of this was so successful, but mostly because neighbors got to know each other. That's what the residents say. Yes, it was great. Some footprints went up, some footprints went down, but they really got a stronger sense of neighborhood connection. And so this was repeated across multiple neighborhoods in Vancouver subsequently over the next 5 years. Some communities, in addition to Vancouver, Saanich, the district of Saanich, is using this input, as I mentioned, mostly for climate and resilience in scope 3, but we worked with bioregional and looked at other municipalities around the world as tested this out as well. So here, cities and citizens are working together with businesses to try and reduce their ecological footprint to live within one planet. And so for me, this is really exciting because now we see the transfer from climate, District of Saanich, this is still District of Saanich, but now moving into the ecological footprint. So the Center for ecoCities, we are producing tools and training and applied research to continue to advance the application of ecological footprinting at the local level, integrating it with the ecoCity standards, which is just building out ways to think about living within ecological planetary boundaries. And a shout out to Christina Olson from our team and Ryan Mackey, who recently adopted the ecoCity footprint tool to create archetypes for municipalities all across our province so they can look up their scope 3 greenhouse gas emission inventories and their ecological footprints. And I can't show the drop down, but where it says Metro Vancouver, you can drop down and pick any municipality in the province. We're also developing a lighter footprint app, have been for many, many years, but just about to launch. And so this links to the city data so that citizens can then compare how their own footprint compares to the average in their city. And that's all I got for now, but excited to be here and share the conversation and where we go to next. Thank you.
So our next presentation is from Peri Dworatzek. Peri is a PhD student at York University in the Faculty of Environmental and Urban Change. Peri studies ecological economics, focused on ecological footprint calculators and how they can be tools to incite behavioral change in the context of needing socioeconomic societal transitions. Peri is also the partnership coordinator for the International Ecological Footprint Learning Lab, which is hosting this webinar. And Peri has co-produced 3 editions of the National Ecological Footprint and Biocapacity accounts. Peri also assists the Scientific Advisory Committee of the Footprint Data Foundation in her role as secretary. And Peri is also the secretary to the Environmental Studies Association of Canada and on the editorial board of Women in Environment International magazine. Welcome, Peri. Over to you.
So this presentation is on a project that I started in when I was doing the master's program at York University, and it's taken a couple of years and sort of finishing it up now as I'm starting the PhD program. So this project was to calculate ecological footprint and biocapacity for Ontario municipalities. You could sort of interchange that word with cities, communities. You'll see in the presentation I refer to them as census subdivisions, which is just another word to refer to this geography. So this project started as a desire from the Rural Ontario Institute, a nonprofit organization in Ontario, to create a community well-being dashboard that provides data for local level data for rural areas in Ontario. This is part of their larger community well-being project. And so their dashboard includes lots of other data. But what they were finding when creating this dashboard is that there was limited environmental data that allowed people to understand their impact related to their economic activity. So ecological footprint fit this gap exactly. And so now ecological footprint has been incorporated onto their dashboard. So this research started out as a pilot project. It was tested out on a few municipalities. And then once that proof of concept design was proved to be successful, we expanded it to all municipalities, or as I say here, census subdivisions across Ontario. So that's about 577 municipalities or cities, I'll call them. So really exciting to have it produced on this wide scale for all across Ontario. So here I have a screenshot of what the dashboard looks like. You can access it on the Rural Ontario Institute website via the QR code, or there's a link at the bottom that I can put in the chat after the presentation. Right now it's showing for the city of Toronto, but over here on the region, communities and community types, you can select different communities and select different aggregations. So it allows for a lot of possibilities of analysis. And then it breaks things down by biocapacity, footprint, the biocapacity balance, as well as the different household subcategories of consumption. And you can see the different ecological footprint components here on the right side. So I'll turn it over to a bit about the methodology for how we calculated these accounts, then turning to some results, and then I'll share sort of discussion points on why this data is valuable for different stakeholders. And then I'll end it off with opportunities that we hope to see in the future. So for the methodology, I'll break it up into footprint and biocapacity, but for both sides, this sort of reflects a top-down methodology. So sort of in an opposition to what Jennie was just talking about, but at the same time, both methodologies use aspects from each side. So when I say top-down methodology, I'm referring to applying scaling factors to different coefficients from starting out as a more aggregated set of data. So that more aggregated set of data starts with the National Ecological Footprint and Biocapacity accounts that are produced at York University by students at York and at the University of Iceland. And from there, the Canadian Consumption Land Use Matrix was produced using GPAP version 10 economic data. And a consumption land use matrix basically is a multi-regional input-output analysis table that also combines different land uses and different land covers that relate to the ecological footprint components. So from the Canadian CLUM, then we created the Ontario CLUM. And then from there, it was able to be scaled, including national accounts data, to be scaled to the census subdivision level. So you can see how that sort of reflects the top-down methodology going from a more aggregated set all the way down to the community level. And so you might be wondering, how does one move from these more aggregated sets to a more disaggregated set of data? And largely for these examples, that was done with Statistics Canada data. Specifically for this project on the community level, a lot of data from the 2021 census was used. So things like population, income, different forms of commuting and different durations of commuting, number of people that live in a household, the type of household, energy use per household, and then annual rates of gross fixed capital formation as well. These data points were applied in scaling factors to the different coefficients that are on the consumption land use matrix to be able to scale to the community level. And there's a ton more information in a methodology report that I'm not going to go through now. So I'll quickly turn to biocapacity before showing some results. Very similar to the ecological footprint, starting at the national level data, the Ontario report was created using some national level data along with Ontario provincial data. But an important innovation made for this project was in the inclusion of wetlands as a component of biocapacity. Wetlands make up a significant portion of Ontario, particularly in Northern Ontario, and they're also a source of carbon sequestration. So it was a really important innovation when scaling to the province of Ontario, and one that was kept up for the community level as well. So for the Ontario report, different scholarly articles, data from Ontario GeoHub, and then Ontario provincial data from, for instance, the Ministry of Natural Resources, was used to create different parameters to be able to scale to the province of Ontario, which then was able to be used for the community level as well. So really what needed to be done for the community level was taking geographic files to be able to find the boundary of that specific community. So boundary files from Statistics Canada were used, Ontario GeoHub data on the land cover and land use. Then to go into this equation that I've just color coded based on the different where the data was being taken from. So the Canadian yield factor, global intertemporal yield factor, and equivalence factor were taken from the national accounts, the Ontario relative net primary productivity, and the relative yield taken from the Ontario accounts. And then the census subdivision hectares was really what was done for this instance to be able to scale to the community level. Okay, now we'll turn it over to something a bit more exciting, which is some results that we have from this project. So something that we found was that there is quite a range of ecological footprint and biocapacity across the province, which is maybe not so surprising because of how large the province is, but there's also many similarities between different community groups and different communities. So in total, there's 577 census subdivisions across the province. 329 are rural, 101 are urban, and 147 are Indigenous. And this goes with the classification from the Rural Ontario Institute that's adapted from Statistics Canada. And one thing I'll mention is that on the dashboard, you won't be able to find specific results for the Indigenous communities out of respect for data sovereignty for those communities, but we have the aggregation of Indigenous communities as a total, and then we include that aggregation in the province of Ontario as well. So ecological footprint for these communities ranged from 0.11 global hectares per capita to around 11.68 global hectares per capita. And biocapacity had an even wider range from starting again at 0.11 global hectares per capita to roughly about 10,000 global hectares per capita. So you can see the wide range this shows across the province. And so what does this look like if we plotted this on a scatter plot? It's a little bit difficult to see at the moment because you can see so much is clustered around a lower biocapacity, but we have a few sort of outliers that have a larger biocapacity. So what we can do is sort of remove those so we can see where a lot of communities are clustered around. So specifically between 4 global hectares per capita for ecological footprint, between 4 to 8, you can see a lot of communities have this range of ecological footprint. And between 0 to 10, there are also quite a lot of communities having that biocapacity. But for instance, rural communities in the orange outline of the circle, they have a much wider range of biocapacity and of ecological footprint, from even reaching above 9 global hectares per capita all the way down to just above 4. We can see that the urban communities in the black circles tend to have somewhat of a higher ecological footprint and of course less biocapacity, which is to be expected. And then the Indigenous communities tend to have a lower ecological footprint and higher biocapacities. And I'll just say these graphs that I'm sharing in a couple maps are currently in press to be published in the Journal of Climate Change Policy and Economy. And so we also can compare specific municipalities between each other. So these 10 municipalities here from Markham to Brampton contain roughly about 50% of the Ontario population live within these 10 municipalities. And so the ecological footprint of these cities ranges from 5.3 up to 7, which all are lower than the Canadian 2020 average of ecological footprint, however significantly higher than the world ecological footprint. And sort of the Ontario average is sort of right in the middle with a couple that are lower and some that are higher. So lots of comparisons can be made between communities and also between different geographies as well. And then we can disaggregate it even further to look at the different proportion of household ecological footprint. So splitting it up by housing, goods, food, services, and transportation, we can see what consumption takes up the most of the household footprint. So it isn't the whole ecological footprint because there's still government and gross fixed capital. So it's about roughly 60% of the total ecological footprint. But something interesting to note is in this research that transportation of the household ecological footprint tended to be quite a bit higher in comparison to some other research that found food to be one of the larger footprint household components. So that was something interesting to compare to other research, especially research that's done on European cities. And then I'll show a couple maps for biocapacity. So this is the biocapacity of southern Ontario, which you can see is largely cropland and grazing land, so used for agricultural lands. This zone zoomed in at the top is Ottawa and the surrounding area, which does have some more forested land for biocapacity and wetlands in comparison to Toronto here at the bottom, which largely is built up land, more of a result as a higher population density. And then we also have the whole province of Ontario, the biocapacity for the whole province. So this is what it looks like if you mapped it out. And to no surprise, really, it sort of makes sense that it fits within the different ecozones of Ontario. So the Mixedwood Plains ecozone here in the south is largely agricultural lands, cropland and grazing land. This sort of middle portion of forested land, forest land biocapacity is the Ontario Shield. And then to the north, the Hudson's Bay lowlands is largely wetlands with some forests as well. And then these two zoomed in regions, the top one is for Sudbury and the surrounding area, which is interesting because it has some extraction and low biocapacity, some more barren lands. And then Thunder Bay in the surrounding area here on the bottom has some built up land, but largely forested land and wetlands. So I'll turn it over to discuss why this data is important to be able to have for different stakeholders. So one of the key benefits of ecological footprint and biocapacity is that it's a powerful communication tool, being able to simplify complex information about our economic behaviors into this single metric. And having this data open access on a user-friendly sort of platform, on a digital data platform, is really key to maximizing the value that it has as a communication tool. There's also the ability to make comparisons, as I've shown, using the national accounts as the source of trends for average per capita. It allows for other city-scaled accounts to be approximated from different years. So comparisons can be made between cities in different years, in different places, in different countries. There's also possibilities for quantifying natural assets. Several cities in Ontario and other provinces in Canada have participated in a municipal natural assets initiative that aims to standardize accounting of natural assets as aspects into a municipal balance sheet. And one way of anchoring this framework is to ecosystem services, but sometimes it can be more useful to anchor this to land use and land cover, which is exactly as ecological footprint and biocapacity do. There's also opportunities for cities to use this data to meet climate and emissions targets. To my knowledge and to my colleagues' knowledge, no Ontario cities have done this yet, but there are examples of cities around Canada, like Jennie mentioned, in Vancouver and Calgary as well, that have used ecological footprint as a metric to meet climate targets. As well, the Ontario Biodiversity Council uses ecological footprint as a metric of human pressures on the environment. So having this data available and open access will hopefully just lead to more opportunities for cities to start using it. But I think we need to really work on that barrier that Jennie was mentioning about being able to share and make this data understandable to different city officials. So I'll touch on lastly what opportunities there are for the future now that this data is available. The Ecological Footprint Initiative and the Rural Ontario Institute are still partners, of course, so hoping to update and expand this data so that there is time series available so we can make comparisons between progress or otherwise. ROI is also continuing to engage stakeholders across the province, including municipal officials, the general public, as well as Indigenous communities on data sovereignty. We can also apply a similar methodology to other cities and regions now that we have a proof of concept design for generating ecological footprint and biocapacity on such a large scale. It's possible to extend this methodology to other areas and cities across Canada and other provinces. And now that we have more and more students coming into the International Ecological Footprint Learning Lab training program from York University, BCIT, and the University of Iceland, it's possible to engage students in this research for their master's or their PhD, which was exactly my case as I had done for the master's and now finishing it off in the PhD program. And I'll end off by saying that there's more analysis that's possible with these results in relation to other indicators such as climate and environmental indicators or social indicators such as life satisfaction. Statistics Canada has municipal quality of life indicators, for instance, for all census subdivisions. So it would be interesting to have some comparisons in relation to ecological footprint. So thank you for listening to my presentation. That's the QR code again if you want to access the dashboard. And feel free to send me an email if you have any questions after the event. I look forward to hearing questions and discussion.
Thank you, Peri. And indeed, thanks for taking the national accounts and the provincial accounts of Ontario to new places and new methodological spaces, if I could say it that way. So about Les. Les is a professional planner at the City of Calgary, holding an MA in Cultural Anthropology and an MSc in Geography, and with diplomas in GIS and photogrammetry. Since 2007, Les has been developing a quantitative method of measuring sustainability within a GIS context for policy analysis and policy planning. He chooses ecological footprint as a basis of measure and has estimated the ecological footprint and its components, including the carbon footprint for each postal code within the City of Calgary. Isn't that amazing for deriving it down to that aspect of locality? So Les is based at the City of Calgary. The City of Calgary is in the province of Alberta within Canada, sort of halfway, not quite halfway, but midway or partway geographically between Jennie joining us and Peri and I, more in the central part of Canada. And so just very quickly to share some things on Les's behalf, Les has been engaged in doing analysis of ecological footprint going back quite some time. And what's awesome is that even though he's approached this out of personal interest and commitment, because like he is not an academic, he works as a planner at the city. Nevertheless, he's been that committed to doing that, and he's also even published academic papers as well to share his findings with the rest of the world. And these papers go back to the year 2011. And there was a more recent paper that he published with the title of Census Villages and the Ecological Footprint, Alternative Data Sources, Policy Analyses, and Communication. And what I'll do is I'll just post into the chat here the title of that and the link to the DOI link if you're interested in checking out this publication of his, which he was to speak to. I wanted to share a few visuals from that presentation because I think they're really great ways of conveying some insightful points that he found from his research, and a great complement to the visuals that Peri shared and also those that Jennie Moore shared as well. So this is drawing from the paper that's published that I shared the link to. I wanted to share a few visuals from that. Here's a visual of the ecological footprint of what he calls census villages, which is down to that local level of the sort of postal code level within a city. And so this is just showing how, like, with having access to data that enables us to resolve it at that spatial scale, it's really amazing what we can derive from that. And in this visual, what we're seeing here is the distribution of the ecological footprint by those census villages, and the count of how many of those census villages or components of the city are within these different realms. And so you've got a mean of 7.4 global hectares, but then of course you've got some at the lower end and some at the higher end, including those at the higher end, even with 9 planets plus. And that's the way that Les was communicating the significance of ecological footprint relative to the planet's biocapacity as one way of anchoring that on a local scale to tie it to the global as well. So really quite interesting here, because this enables us to understand the variability even within a defined geography of a city as well, which is, really quite obviously important from a land use planning perspective, also from a conservation perspective, environmental policy perspective, and so on. Another image to share from this is looking at the different components of what we can call consumption that takes place within the city of Calgary, and then relating that in terms of ecological footprint. Again, showing the distribution of that within that city, the frequency and distribution of, for example, the proportion or the number of components within the city that are at the lower versus higher end, for example, from a housing perspective, from a personal transportation perspective. from the goods consumed at the household level and from services as well. And of course, these are the sort of probability distribution sort of functions plotted, but we can also, of course, relate that in terms of mapping it and what it looks like across the landscape as well. Really powerful visuals, and also, again, emphasizing that distributional aspect, which I think is really helpful to keep in mind. And that's the sort of one of the key virtues of engaging in ecological footprint, because it is scalable from the super local up to the global. We can engage in this kind of analysis distributionally within a spatial context, which is really quite awesome. This is another way to visualize that, which is the within the urban region, the sort of the number of planets as the metric, sort of in bubble shape, sort of clustered across the landscape. So you can see just quickly from this where the concentration of high consumption, high ecological footprint living is as compared to other parts of the city, for example. This is really quite interesting as well. This is looking at, so this is focusing just on emissions, so not the broader ecological footprint, but just one component within that. And so what's amazing is that because Les works in the city of Calgary, he's able to access utility level data, which is one of the key bits of data that he was able to use to derive this at the super local basis, and also to have it over time as well, which is really, really quite awesome, because it allows us to derive awesome insights such as this. And so this is looking over time from the 1970s up to the present. The emissions of CO2 per square meter of housing. So in other words, this is the intensity, the amount of greenhouse gas emissions per square meter of housing over time. And not surprisingly, on a per area basis, we've seen improvements in efficiency by which we, heat and cool spaces and residences and so on. So that has declined over time. You can see the change in terms of gas and electric. One thing of note in this geography, the electricity up until this point was almost entirely generated by the combustion of fossil fuels. Since then, Alberta has decarbonized its electricity. It still generates electricity from burning fossil fuels, but not with the same carbon intensity. They have shut down coal-fired generation in that province, in the same way that in Ontario, we shut down coal-fired generation here some years ago. But there's still gas used to generate that, but of course with a lower emissions intensity. But so also showing, though, the differences between those that are heated directly with gas and electric. At the same time, this is a plot over this period of the amount of square meters of housing on a per house basis, on an average basis. So the housing size has increased over time, and as it has in many parts. So even though we're getting efficiency with regards to the emissions per unit of area, the amount of area used to house us has been growing over time. So those are some of the interesting aspects that we can engage with data at this scale, of looking at the interplay between scale and intensity, as the way we typically refer to that in ecological economics, let's say, the interplay between those there as well. And just some final comments to share. This is a map. This is not published in that publication, but Les was a guest in a class that I taught last term and shared this image with me, which is, as within a city context, this is the results on a ward basis, and the ward refers to the political boundary represented by a city councillor at the city. And so this is within that, again, on that neighborhood basis, but tying it into the ward as to how to engage in seeing that distribution. And what's awesome here in this image here, again, within these wards, showing the distribution of those, but then also showing, in this case, zero net home, which exists in this ward. And so there's a person, a great champion of sustainability and reducing emissions, who has retrofitted the very typical house in this area, in this ward, and disconnected from the gas line and made amazing improvements and to lighten the load from an emissions and ecological footprint perspective in such a dramatic way to show this is what leadership looks like within the ward. This is what leadership looks like in terms of reducing emissions and reducing ecological footprint. There's the challenge to the rest in the ward, and indeed the challenge to all of us as we think about scaling this locally and using that to inspire change and so on. Les is also engaged in making sort of online sort of engagement tools to engage people as well. And so has produced this on the Kootenay Village Challenge, a WordPress site that he manages. There's different versions of this for different regions. This is in the Kootenay region, not in a different way, but he's got a few of these where to try to sort of gamify this, where you can take on the challenge and then input data and stuff and see how you can compare to others and so on. So lots of interesting potential there. I just wanted to share that on Les's behalf in terms of how you can engage in this. So let me conclude this webinar with my thanks to our presenters, Jennie Moore and Peri Dworatzek, and also our best wishes to Les Kuzyk, and for being able to share his research that's been published and which I spoke about briefly. And thanks to our audience for attending, and thanks to the Ecological Footprint Learning Lab, IEFLL is the acronym EIFL, for hosting this event in partnership with the Faculty of Environmental and Urban Change at York University in Toronto, Canada. If you're interested in connecting with us, potentially to explore ways to collaborate on your training or research, please email us at iefll@footprintpartnership.net or by connecting through any of our presenters today. We'll look forward to connecting with you on the ways to engage in training and research, knowledge mobilization, etc. This extends not only to those who might have academic affiliations, but also and especially those who are outside of academic institutions. If you're involved in an organization, maybe it's a business, maybe it's a not-for-profit corporation, maybe it's a charity, maybe it's an advocacy organization. Maybe you're just a very keen sort of public participant in various processes and so on. Locally, we are very keen to have awesome and keen people join us in this partnership, which is a multi-year partnership with anchors at York University, BCIT, British Columbia Institute of Technology, and also University of Iceland as well. And we're broadening that through many of the organizations and participants who are joining us on this call. So thank you so much. All the best to all of you. And I guess maybe just end off with Jennie's phrase as she shared before: may we shrink, share, and regenerate. All the best. Take care.